All right, let's dive into one of the biggest, most mind-blowing mysteries in all of modern physics. We're talking about a paradox so deep it puts Einstein himself in a head-to-head battle with quantum mechanics, a fight for the very soul of the universe. Welcome to the cosmic detective story of the black hole information paradox.
The whole thing really boils down to this one simple, but honestly, kind of terrifying question. When something falls into a black hole, we know it's gone for good. But what about the information that made that thing unique? Its very identity, its history. Where does all of that just go?
So here's how we're going to crack this case. First, we'll set the scene of this cosmic crime. Then, we'll meet the prime suspect who blew the whole thing wide open. We'll investigate the initial leads, uncover a truly revolutionary clue, and finally, confront a shocking new twist that's going to take us right to the very edge of reality itself.
Okay, so to get a handle on this, we first have to understand the two fundamental laws of the universe that are just in total opposition here. We're talking about the absolute pillars of modern physics, and the thing is, when it comes to black holes, they can't both be right.
First up, let's talk about our victim, quantum information. The best way to think about it is like the universe's ultimate, unerasable logbook. It's the unique blueprint for every single particle, its location, its speed, its spin, the whole shebang. Now, according to the laws of quantum mechanics, this information can get scrambled up, it can be hidden, it can be rearranged, but it can never be destroyed. That is a fundamental law, just like the conservation of energy. It's a big deal.
And this, right here, is where the trouble starts. You've got Einstein's general relativity on one side, telling us that a black hole's event horizon is a strict one-way street. Once you're in, nothing gets out, period. But then you have quantum mechanics on the other side, insisting that information is forever. So, what happens when permanent information meets an inescapable prison? One of these bedrock laws of our universe has to break.
For a long time, physicists could kind of just sweep this under the rug. It was a weird theoretical headache, sure, but not a full-blown crisis. But then, in the 1970s, a guy named Stephen Hawking came along and made a discovery that changed everything.
Hawking basically dropped a bombshell on the world of physics. He figured out that black holes aren't perfectly black after all. They actually leak a tiny bit of radiation. We call it Hawking radiation, and over immense amounts of time, they completely evaporate. And here's the kicker. His math showed that this radiation is totally random. It contains absolutely none of the information that fell in. The universe's logbook wasn't just locked away inside the black hole. It was being systematically burned, page by page. This was a huge problem. It meant a fundamental rule of quantum physics was just wrong.
The stakes here were just unbelievably high. You had physicists like Stephen Hawking, John Preskill, and Kip Thorne making this famous bet on the outcome. Hawking was so sure that information was lost forever that he bet against it being saved. This wasn't just some friendly academic argument, this was a battle for the very future of physics.
So, after Hawking threw this giant wrench in the works, physicists scrambled to find a way out. This led to three main lines of investigation. You could call them the three main suspects for how to solve this cosmic crime.
Okay, let's look at our suspects. Suspect number one. Maybe the information is just lost. Hawking was right. This is the simplest option, but it's also the most terrifying because it means our entire understanding of quantum mechanics is broken. Suspect two. The information escapes. It somehow, very subtly, encodes itself into that faint Hawking radiation. This would save quantum mechanics, but it seems to require information to travel faster than light to get out of the black hole, which is a big no-no. And finally, suspect three. The information remains. Maybe the black hole doesn't evaporate completely. It just shrinks down to a tiny, stable nugget, a remnant, that holds on to all the information. But that creates its own mess of problems, like potentially having an infinite number of these things.
For years, the case was just completely stalled. Every path seemed to lead to another paradox. And then, in the 1990s, a totally radical new clue emerged from the wild world of string theory that just turned everything on its head. Get ready, because this is a real mind-bender. It's called the Holographic Principle. It's the idea that our entire three-dimensional reality might just be a projection, like a hologram, of information that's actually stored on a distant, flat, two-dimensional surface. Now, what this means for our case is just profound. Maybe the information never really falls into the 3D black hole at all. Maybe it gets smeared out and stored on the 2D surface of the event horizon itself. And suddenly, the case started picking up speed. You had Hawking kicking the whole thing off in '76. Then in the early '90s, you get 't Hooft and Susskind with this wild holographic idea. And by '96, Strominger and Vafa used string theory to show how, in principle, a black hole's surface could actually store all that information. It really felt like the case was finally about to crack.
But just when it looked like the holographic principle might save the day, the universe wasn't done throwing curveballs. A new, even weirder paradox emerged. Yeah, the plot was about to get a whole lot thicker.
So to make this whole holography thing work, physicists proposed something called black hole complementarity. And the idea is that reality itself literally depends on your point of view. So if you're the unlucky astronaut falling into the black hole, you just sail right past the event horizon, no big deal. But to your friend watching from a safe distance outside, they see something completely different. They see you get flattened, almost like a pancake, and your information gets encoded on the surface of the horizon. And the wild part is, both versions of reality are supposed to be true at the same time. Yeah, I know.
But wait a second. A copy of the information inside the black hole and another copy on the surface? That smashes right into a core rule of quantum physics called the no-cloning theorem. It's an absolute law that says you cannot make a perfect, independent copy of a quantum state. You just can't do it. It's a fundamental no-no that keeps the universe from descending into paradoxes. So you can't have the same information in two places at once.
Okay, so something's got to give. In 2012, a group of physicists proposed a solution, and it was dramatic. They said there must be a firewall, a wall of insanely high-energy particles right at the event horizon. This wall would just incinerate anything trying to fall in, destroying the information and ensuring only one copy, the one on the surface, exists. This solves the cloning problem, but it creates a brand new one. It completely violates Einstein's theory, which says crossing the event horizon should be totally unremarkable. Classic.
And that pretty much brings us to today. After almost 50 years of investigation with all these shocking twists and brilliant clues, where are we with this cosmic cold case?
Well, the bottom line is the case is still wide open. But see, the black hole information paradox isn't a bug in our theories, it's a feature. It's like a giant flashing red light that shows us exactly where our understanding of the universe completely breaks down. The final solution is going to require a whole new theory of quantum gravity that finally unites Einstein's world of the very big with the quantum world of the very small. The investigation is far from over.
This entire mystery forces us to ask some absolutely staggering questions. I mean, if the holographic principle really does hold the key, what does that say about our universe? Is it possible that everything we see and feel and experience, our entire 3D world, is just a holographic projection coming from the edge of the cosmos? The case might be unsolved, but the clues are pointing to a reality that is far, far stranger than any of us ever imagined.